So I've got some tap water here, straight from the tap. I'm just going to run that through, a couple of these through the filter. Just washing out the excess salt basically. It's filtering through, doing its thing. I'll just leave it there for a minute and then do that again. So that's my water filter, good to go really. The way it works is well, it works on surface area. Okay, I'm going to talk about a bit about the science of it in a little while. But that's it's ready to go now. I can use filtered water. I could drink that filtered tap water. A little word about caution. Okay, what water filters are at this level is they take reasonably clean tap water and they make it a little bit cleaner. It filters out some minerals and heavy metals, but what it doesn't do is when I put my first jug of salty water in there, the water coming out the other side still tasted salty. So I wouldn't use it to filter septic water or stagnant water or pond water or anything like that without a few additional levels of filtration. The carbon would need to be more tightly packed for a start and probably drawn through it with a pump, and you can also filter out debris and things like that, not just with a cloth but with gravel, which is known to be a particularly good water filter as well. So that could be an additional layer of filtering you could add to your filter if you needed to, if you were filtering pond water or stream water, for example. I'll show you, I've got a water purity tester here, and I'll show you the difference between tap water and filtered water, and it measures it in terms of parts per million impurities, and there isn't an awful lot of difference, and I'll show you that in a minute. So it takes tap water and makes it a little bit cleaner. And also keep in mind that if you're using an oven or you're using boiling hot water, to be careful that you don't burn yourself. If you're underage, make sure you're doing it with a parent or a guardian. But it's not particularly complicated. The science behind it is quite complicated, the way it works, and perhaps I'll show you that towards the end of the video. What I've done there is I've just put the filter I made on the top of the filter kettle, or jug. I'm just going to filter some water through it and then show you the difference between tap water and filtered water in terms of impurities in parts per million. So here's some plain old tap water. I'm going to put most of that in there. And then I'm going to measure them with the impurity tester. The other thing to think about is the resin. The resin is quite often actually made from a polystyrene polymer, and obviously that's a form of plastic, so I don't know what would happen to it in the oven chemically, whether it would melt or if it changes its properties in any way. So you need to think about that and also take responsibility for that. This is my water purity tester. It's called a TDS, which stands for Total Dissolved Solids, and basically there's two prongs there, and you put that in the water and it measures the resistance, and from that it can tell how far deviated it is from pure water being 0. Just switch it on. Just it's at 0 at the moment. We're just getting a reading, and it looks like about 185 parts per million. And let's see what we get with filtered water. I've rinsed the glass out with filtered water. If you leave tap water in it, when you put filtered water in the glass, obviously you're going to get more impurities, so rinse the glass out with filtered water, not tap water. Let's just get some nice filtered water in here. This is being filtered twice, by the way. Take the cap off. Switch it on, zero it. There we go, zero. And let's see what the moment of truth is. Remember we had 185 before. And we currently have more impurities. Okay, what's going on with that impurity test is I'm actually measuring the remnants of the salt solution that I flushed through it, which reactivated the resin. And if you think tap water is 185 and I'm measuring some impurities of about another 40 parts per million of salt molecules, it's actually a very small amount, and the salt won't hurt you at all. It's only table salt that you put on your food anyway. And what will happen is as that salt will flush through, then the water will become more pure. Now I think the reason why we have more impurities is because I'm still washing salt, the saline solution, out of the granules, and when that's been flushed through a couple of times, I think that will come back to normal, I'm pretty sure. And the only other thing I can mention is the cloth that you put across the top of the bottle to catch the mixture, the resin and carbon granules, to stop it falling out. Make sure it's a quite tightly woven cloth if you use a cloth, and also make sure that little bits of cotton aren't coming off it and getting into your water. So here's the water I just tested, salt and all, and point the camera in the right direction. Tastes fine. Can't taste any chlorine in it. The water's nice and soft, and I'm quite happy to drink it, to be honest. So that's it basically. Have fun with your own experiments. Don't take my word for it. Try it out for yourself. Be careful, don't get burnt, and enjoy. And if you get any breakthroughs or anything I should know about, leave it in the comment section below. And if you like my video, please like it, rate it, give it a thumbs up, and what's the other one? Comment, rate and subscribe, they say, don't they? Well, anyway, if you like my video and you'd like to see more, please subscribe and share it with your friends. That's my little video. Thanks very much for watching. In the top of the get the masher out of the way, carbon molecules, or in another video if I don't get through this one today. And another thing to think about is the resin, the ion. I can't even keep remembering that. It's ridiculous. I'll just call it resin. That's my little video. Thanks very much for watching.